Okay, this is serving as your first set of notes on solving systems of equations by graphing, and you need the page that is titled Steps to Solve Systems of Equations by Graphing. The notes are broken up into sections on each of the following slides. So first, one way to solve a system of equations is to graph the equations on the same coordinate plane. And there are 5 easy steps that you're going to follow to do this. Put both equations in slope-intercept form, which is y equals mx plus b. Graph your first equation. Graph the second equation. The point of intersection is the solution, x comma y. We write our solution as an ordered pair. And the reason why the point of intersection is the solution is because that's the one point that both lines contain. And then you're going to go ahead and check your solution by substituting the values that you found for x and y into your original equations. Alright, so your first part of your notes have an example for us to do together. You have two equations, y equals 2x minus 1 and 2x plus y equals 3. Y equals 2x minus 1 is already in slope-intercept form, so we do not have to transform that. However, equation B says 2x plus y equals 3. That's standard form. So we need to go ahead and transform that into slope-intercept form. So we can do that by subtracting 2x from both sides of the equation. And we're left with y equals negative 2x plus 3. And so now we're ready to graph both equations. So y equals 2x plus 1 means we have 2x minus 1 means we have a y-intercept at negative 1. And we have a slope of positive 2, which tells us that we increase our y value by 2 as we increase our x value by 1. Now you could also decrease your y value by 2 and decrease your x value by 1 and get the same result. And then you can go ahead and connect your points by drawing a line through them. Mine's a little bit crooked and sloppy, but it gets the job done. And then we have y equals negative 2x plus 3. So now I have a y-intercept at positive 3 and a slope of negative 2, which tells me my y value goes down by 2 as my x increases by 1. Draw another line through it. And you guys should clearly see an intersection point at positive 1, positive 1. So what we need to do is come over to the right and check our solution, because we want to make sure that our solution satisfies both equations. That means it makes both equations true. So our solution was 1, 1, and remember, it's always x then y. And all we're going to do is substitute our x values in and our y values in and see if it comes out equal. So 1 equals 2 times 1 minus 1. 1 equals 2 minus 1. 1 equals 1. Well, that's a true statement. 1 does equal 1. So it works for equation A. So let's try B. 2 times 1 plus 1 equals 3. 2 plus 1 equals 3. 3 equals 3. That also is a true statement. So our solution of 1, 1 does in fact satisfy both of our equations in the system. So our official solution is 1, 1. Okay. Your second page of notes should say special cases at the top. So we're going to go ahead and examine those first. It lets us know easily how many solutions our system is going to have. Okay, so our first special case has us graphing y equals 3/5 x plus 2 and y equals 3/5 x minus 4. So I'm going to ask you guys to go ahead and do that while I do it. And I went ahead and graphed them in two different colors so you could clearly see the two different graphs without there being a problem. And hopefully you guys have the same graph that I have and you can see that the lines are parallel. Well, parallel lines by definition never meet. So that's our first special case as far as systems of equations are concerned. Okay. First, you should know that parallel lines have the same slope. So if you look at this equation, your slope is 3/5 in your first equation and 3/5 in your second equation. Those slopes are the same, so automatically you should know that those slopes are parallel, or those lines are parallel, excuse me. A system of equations will have zero solutions if the lines are parallel. Okay? And the reason why that's true is they never intersect, so there can't be an intersection. They can't have a common point if they never meet. So next we're going to be graphing y equals 1/2 x minus 2 and y equals 3/6 x minus 2. So we're going to start at that y-intercept of -2, and we're going to go up 1 over 2. And I drew several points in this time. And I'm going to move on to the second one, which also has a y-intercept of -2. So that's going to fall right on top of our first y-intercept. And now I'm going to go ahead and draw that line, and you're going to see it's going to completely cover up our first line. Okay? So that's our second special case. One line is on top of the other line. Lines are the same if they have the same slope and the same y-intercept. Now if you look at our equations, it may look a little bit different. It's clearly have the same y-intercept of -2. Our first one has a slope of 1/2 and our second equation has a slope of 3/6. However, if we simplify that second equation, or the slope in the second equation, now we can see it's exactly the same. A system of equations will have infinite solutions if the lines are coinciding. So when we have lines that lie on top of each other, we call those lines coinciding, a very fancy word. And finally, we're going to be graphing the system y equals 2x minus 5 and y equals 4x minus 7. So I have a y-intercept at -5 and the slope of +2. And the second equation of y equals 4x minus 7 is going to start down at -7. And it has a slope of 4. And already I have found an intersection point. It's right here at -1. I'm sorry, at +1, -3. Okay, so a system of equations will have one solution if the lines have different slopes. In this case, we got the solution 1, -3. And of course, we can plug it into the equations and check. According to us, -3 should be equal to 2 times 1 minus 5. -3 should equal 2 minus 5. -3 should equal -3. And it in fact does. So it works for the first equation, second equation, negative 3 equals 4 times 1 minus 7. Negative 3 equals 4 minus 7. Negative 3 equals negative 3, and that checks as well. So the very bottom of your page, there is a summary section. 2 lines that intersect have one solution. They also have different slopes. Parallel lines have no solution, and they have the same slope but different y-intercepts. Same lines have the same slope and the y-intercept. They have infinite solutions. Remember, these are also called coinciding. So at this point, you should be ready to complete practice 1, 2, and 3 for the graphing, solving systems of equations by graphing. Just make sure you refer to these notes if you get stuck.